Today we'll be discussing Leetcode 169 majority element. And to solve this one, we're going to be using the Boyer-Moore majority vote algorithm. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. This algorithm enables us to find the majority element in O of n time and constant space. We're going to iterate through our list, and at each element, we're going to check if the candidate equals the current element. If it does, we're going to increment its votes. If we get to an element and the votes are at 0, then that element becomes our new candidate. Lastly, if we come to an element and it is not the candidate, then we're going to decrement the votes by 1. Whatever element ends up as our candidate is our majority element. Okay, we saw a nice little animation explaining our code. Now let's just write it out by hand. We're going to have a couple of variables. We're going to have our candidate, which is going to start off at none. And then we're going to have our votes, which we're going to start off at 0. Now let's create a list. We'll have nums. We'll just do the example from Leetcode, 3, 2, 3. And now we're going to iterate through nums. We don't need the index for this algorithm. So using Python, we'll say for n in nums. So let's go ahead and write down what n will be for the first iteration. N will be 3. If n equals our candidate, and I'm just going to put C for shorthand because I can't fit all that here. My handwriting is giant. Then we're going to increment the votes by 1. Else if the votes equals 0, remember what we do here? Then candidate becomes n. Lastly, our else statement, our count, or our votes, will be decremented by 1. And then when we get to the end, whoever's the candidate, that's our result. So we're just going to return candidate. So let's go through this. N equals 3, candidate equals none, and votes equals 0. So n equals 3. Does n equal candidate? No. Does votes equal 0? Yes. So candidate becomes 3. Now we're going to go through again. Does n now equals 2. Does n equal c? No, it does not. Is votes 0? Why, yes, it is. So c now becomes 2. Now we're on 3 again. If n equals c, does it? No. Does vote equal 0? Yes. So the candidate becomes 3, and we return c. The majority element is 3. Okay, so finally, here we are in Leetcode. We're going to set up our variables. We'll do C for candidate, which is going to start at value none. We'll have V for votes, which will start at 0. Now we're going to iterate for n in nums. And here's our algorithm. If n equals C. If n is our candidate, then votes gets incremented by 1. Else, if votes, V for votes, equals 0, then our candidate is set to n. And lastly, if our candidate does not equal n, then we take our votes and we decrement it by 1. And once we get through that iteration, we are going to return our candidate. Let's go ahead and run this and submit it. And as you can see, our time complexity, O of n, and our space complexity, this is where the real exciting part is, it's in constant space. Now, when we're counting elements, usually you might think hash map, and that's a completely valid use for a hash map. But in this instance, why not just solve it with constant space?